468 in your text. This is the law up here, sine of I divided by sine of R equals n, the index of refraction. So in our sample problem it says light travels from air into water. Here's the index of refraction of water. And if an angle of incidence is 30 degrees, what's the angle of refraction? Okay, so what I want to do is to want to show you, so here is, we're going to go air up here, here's water. The angle of incidence is right here at 30 degrees. So this is the normal right here, the straight up and down line there. So this is 30 degrees. 30 degrees. The angle of refraction. Now, a couple things that you're going to notice, if you don't notice this already, I mentioned this already, but you'll see that as light travels into a more dense medium, when the speed of light slows down when it goes into a new medium, it always bends a little bbit towards the normal. So the refracted ray is going to have a smaller angle of refraction. So it's going to be a smaller angle of refraction. Now, by how much is dictated by this index. Now, I've over-exaggerated this just a little bit to show you, okay? But we have a light ray coming in right here. It hits the surface of the air or the water, and it's going to slow down, and it's going to bend towards the normal a bit. Okay, so let's use Snell's law here. Willebrod-Snell. All right, sine of I over sine of R equals n. And what we're actually looking for is the angle of refraction. So that's actually R. We're looking for R. We have to solve for R. So those of you that are comfortable with math, this is going to be easy. Those of you that may not be comfortable with math, let me just show you how we're going to do this, okay? So right from this equation, we can plug in all of the values that were given in the question. So n is 133 and 1.33, and always we use the n for the medium that we're going into in these cases. So I'm going to rewrite this down here. This is going to be 1.33. That's going to be the n. We know what the angle of incidence is, and that's 30 degrees. But I don't know what R is, so I'm going to leave R just as R. Okay, so dealing with a simple proportion, we know that we could multiply both sides by R, or sine of R, so that can come up here, right? Sine of R can come up here as a multiplication, be done down there. And then we can divide both sides by 1.33. So in effect, this 1.33 trades spots there. So this is what we end up with. We end up with sine of 30 degrees divided by 1.33 equals sine of R. Okay, just going to make a little bit of some more space there. Okay, so as we move through this, again, we're going to solve for R. So let's get our calculators out and let's find out what sine of 30 divided by 1.33 is. So sine of 30 degrees divided by 1.33. Okay. You know what? I wonder if... Let me do degrees. Okay. So we have 0.3759. So this is going to be 0.3759 equals sine of R. Now, when you get to this point, does anyone remember how we can solve for R now when we get to this point? Who remembers what we do? Anybody? Second function sine. Very good. Yes. So we do second function sine. So that's the sine to the -1 of this value. And of course, really, we do that to both sides, and that gets rid of the sine over here. So we have R equals, and you do this on your calculator. And if you have that decimal up, you don't have to retype it in. Just go second function sine, and then you should have an answer button or something function on your calculator. So the sine to the -1 of the answer. So we should have 22.08. To the nearest degree, we're going to go 22 degrees. Okay? So once again, in order to find R, you need to do second function sine of both sides to get your... okay? So that's how you find angle of refraction in this question. Do you guys have any questions about that? Any problems about that? Got it all on the same screen there? No? No questions? All right.